Okay, I want to talk about cooperation and why we're such a cooperative species, its importance for the sort of thing we're all interested in here. That's the first half of the talk, roughly, and the second half is about the relationship between what I now understand you call precarity. The term I'll be using, because that's the term I've been using, is adversity, but it's the same. But adversity is a rather broader conceptually, but we're talking about the same concept, really. The relationship between precariousness, also uncertainty is the second thing I'll bring in, and cooperation. As I think you know by now, I'm an evolutionary biologist, so I'm the odd man out here. So I want to start assuming unfairly, I'm sure, that you know nothing about the evolutionary approach to behaviour, to say something about that approach. So using cooperation as our exemplar, a social scientist asked a question of what people in my field call proximate causation. You're interested in internal states and probably more likely environmental contingencies that influence whatever you're interested in, cooperation in this example, yeah. The evolutionary scientist, so you're asking what questions? Yeah. What are the influences? The evolutionary scientist asks why are those influences there? Why is it that those things influence cooperation and not other things? It could be otherwise. That's a question broadly about history, cultural history or evolutionary history. And these are not in conflict. These are two different kinds of questions. An evolutionary explanation does a biological evolutionary explanation does imply, ultimately, some genetic variation in the population between individuals. It says nothing at all, one way or the other, about how these things develop in the individual. It doesn't assume that behaviours are fixed or flexible, or what you might want to call instinctive, not a word I like. The things I'll be talking about are evolved, I will argue, but they develop in the individual through learning. But we are not a blank slate. We have certain predispositions and biases which are themselves evolved. For non-social behaviour, the evolutionary scientist looks usually for optimal solutions, assuming that natural selection tends towards an optimal solution. When it comes to social behaviours, that's not the right logic. What's optimal for me in a social interaction with you may not be optimal for you. The logic now is to look for the stable solution. When you've reached a stable solution, by definition, it stays where it is. So you're looking for stability. Natural selection will tend, in the evolution of social behaviour, to produce stable solutions. How do you predict a stable solution? Well, the logic came into evolutionary science in the 1970s from game theory, from economics. Game theorists, particularly through John Nash, looked for stable solutions, the Nash equilibrium, as it's called. That was picked up by evolutionary scientists. John Maynard Smith was the important person to do that, to realise the logics were similar, and whereas, as well as I'll show, people don't follow game theory rational solutions, we expect natural selection, by definition, to produce stable solutions. Evolutionary forces will tend towards stability, and then things will stop. If everything stays the same, that's what we've got. So we can make very robust predictions about stable solutions in evolutionary terms. I'm going to start, now we're going to get, with that background, start talking about cooperation. And I'm going to look at the prisoner's dilemma as an exemplar. I was going to go through this in great detail, but I'm not now. I want to spend more time for the later stuff about precarity. But I do want to go through this in a little bit. There are different kinds of cooperation, but the prisoner's dilemma kind of situation is useful to look at in more detail because it's problematic for cooperation, as we'll see. So I'm going to go through this as an example, and you can frame this in different ways. This is a relatively simple way. Can you all see this? The text, yeah. Okay, imagine you have two people, a buyer and a seller. The seller has some goods to sell. The buyer wants to buy it. They come to an agreement about the price. And for the purposes of this example, they decided that the seller will leave his goods somewhere in a bag, and the buyer will leave the money they've agreed somewhere else in a bag. They have two options. They agree to that, or they cheat, and they don't leave the bag in the place. I've cut out all the details. We're going straight to the payoffs. Okay, this is a payoff matrix. I'm sure you're familiar with this kind of thinking. And there are these kind of payoffs. If they both are honest and leave the money, the goods in place, they get, let's say, 3. The first number here is for the seller on the row, and the second number for the buyer. They get, let's call it 3. Doesn't matter. It's just the ordinal relationships between these numbers that matter, not their absolute amount. If both cheat, and they both go to the other's bag and it's empty, it's a lower payoff because they wanted this exchange and they agreed to this exchange. It was beneficial for both of them. So they just go home with what they started out with, which is what they came with. If one cheats, they get a higher payoff because they've got the goods, but they have paid nothing for it, or vice versa. And the one who's cheated gets the least payoff. They've lost their goods, so they've got nothing for it. If you make the comparison, the basic logic is here, without going through every comparison, which I was going to do, is that whatever the other party does, the best thing you can do is to cheat, or what we call defect. And so you end up, this is a Nash equilibrium, this is an equilibrium state, that both of you cheat or defect. You can't do better than doing that. Whatever the other person does, it's better to defect. So you end up defecting. The dilemma, or it's not really a dilemma because that's the rational thing to do. But so that just repeats what I've said. But the point of it is that if you could, let's say, trust each other, you'd be in this square, and you'd have completed the transaction, and you'd have both done better. But because this is the stable point, you don't reach it. Okay, so we don't have cooperation so far, and both parties have lost out. How do we get cooperation, given this starting point? Oh, before getting to that, just as an extension of that, the tragedy of the commons, which I'm sure you know about, is just an extension of the prisoner's dilemma in a group. It's the case where you get overgrazing on the commons, say on the Newcastle commons, one of the greatest commons in England, I think still. Each farmer puts 1 or 2 more cows to graze. Everybody does it, so it's overgrazed and everybody loses. It's a group example of the prisoner's dilemma. So if defection is the stable state, how does cooperation emerge? It's because, and now I'm going to make this argument for, and this is the general way evolutionary biologists and psychologists, the current thinking on this, not just my thinking, for the evolution of cooperation in our species relies on the fact that we evolved in small social groups. Everybody knew everybody else. It wasn't a one-off. It wasn't a one-shot prisoner's dilemma, as in that example. It was repeated. If somebody cheats on you today, that's not the end of it. You can do something about it tomorrow. So in game theory terms, you're into something much more complicated. And there's been lots of modeling of this. And basically, the outcome is that there are all sorts of stable outcomes where you do get cooperation. You end up in the 3-3 cell rather than the 2-2. And you both benefit from cooperation. Basically, because you can reward past cooperations with cooperation in the future, and you can punish past defections by defections. The first important paper on this was by Axelrod and Hamilton back in 1981. It's a nice Robert Axelrod, an economist, Bill Hamilton, one of the great evolutionary biologists of the 20th century, got together over this. When people play the prisoner's dilemma, even one shot, they don't defect. On the first round of a repeated prisoner's dilemma game, people cooperate about half the time, very roughly, and go on to cooperate. So we don't follow even the one-shot defection. And there's a whole story there which I won't go into, but the iterated principal dilemma is quite a good kind of exemplar for the evolution of cooperation. So I've already answered some of this question, how did it evolve? I put some references at the bottom here, not for now, but for later, to a lot of the things, if you want to follow them up. But, as I said, we evolved in small groups, 50, 100, 150. Everybody knew everybody else. And you could punish past defections or reward past cooperations. And the term that kind of encapsulates this was by Richard Alexander, was called indirect reciprocity back in the 1980s. The point is that it's, you want to think beyond the dyad to the whole group. You get to know through observing other interactions and through gossip about other interactions what people's reputation is in terms of cooperation. And those who have been more generous in the past with cooperative interactions are more likely to be chosen in the future by others for cooperative relationships. So the reciprocity doesn't have to be one-to-one, just a dyad. It's indirect. You find out about the nature of other people, and cooperators gain more beneficial relationships in the future. And one piece of real-world evidence for this kind of thing, in fact, was done in my department here in Newcastle, and I and others were unwitting subjects for this. This finding has now been replicated a lot of times. Well, three of my colleagues did this. In the coffee room, there was an honesty box for those who took coffee, put so much in for each coffee. And above where the box was, on one of the cupboards, for a fortnight, there was an image either of a pair of eyes, or alternately, flowers' eyes, for fortnightly intervals. We were all not consciously aware what was of this, but what they measured was how much money goes into the box. And actually, it was controlled for amount of milk, so how much was going, potentially there. And eyes, a lot of money. Flowers, eyes. Yeah? And their paper is called Cues of Being Watched, Enhanced Cooperation in a Real-World Setting. I mean, I won't go into the explanation. It seems we have a propensity to be more cooperative if we think we're being watched, is what it means. And as I said, it's been replicated lots of times now. Okay, that's that game. Now, here's another game. There are lots of games that come out of economics, ultimately, that tell us more about cooperation. The ultimatum game, and if you'd have been here earlier, you'd have been playing this, but you've missed out. What is the ultimatum game? In the ultimatum game, you have two players, and a good frame for this, a simple frame, is that two people walk along the street, there's a £10 note on the pavement, and person A sees it just before person B, picks it up. That's a scenario you give to participants, and you say, okay, if you're this first person, and you just found this by chance, how much of it would you give to the other person, person two? That's their decision. And then person two is asked, do you accept or reject this offer? If you accept it, you share as offered. If you reject it, neither of you gets anything. Right? Neither of you gets anything. What's the rational thing to do is for the donor, the first person, to give the lowest possible amount. And you say, let's say, in £1 increments. The logic of that is to go to the second person and ask what's their rational thing to do. It's to accept anything you're offered, because anything is better than nothing. So the second person should accept, say, down to £1, if that's the smallest unit. So that means rationally, which means selfishly, you should offer £1. And what do people do? They actually offer much more than that. And the rational response, as I've said, is always to accept something that's more than zero. But in fact, people will reject less than about 20%, just very broadly. Now, this is not rational. It's not rational. What is going on? Well, I said, what did you do? But you didn't have the chance anyway. So what seems to be motivating these decisions? I'll show in the next slide that this is probably a universal thing. I might have put these slides the other way around. The motives seem to be, for the donor, is something to do with fairness, to act fairly. And or to be seen to act fairly, going back to the small group origins in our early history, to gain a reputation for fairness. For the responses, it's to respect a fair offer, to punish an unfair offer, and it's spiteful to punish this offer because you could have had £1 or £2, and you're paying that £2 to punish an unfair offer. And also, therefore, not to gain a sucker's reputation. So there's the immediate possible gain, and there's the reputational consequences to take into account. So I'm not going to go into the detail of this. Can come back to it if you want to discuss it. But to show that there are cultural variations in this, Western students give 40-50% away. There was a study of 15 small-scale societies, a multi-centre study around the world, and we can look at this in detail later if you like. But these are the different societies, and these show the amounts given. The size of the circle is proportional to the proportion of people who gave. So a lot of society, and it's ranked to the more generous going up. So many societies give about half, and down here to 40%, 30%, down as low as 20%. And the slightly shaded area is the average rejection rate. So some will reject around 50%. And there are interesting economic and cultural influences that help to explain these differences, which we can come back to if you're interested. Okay, to round off, it's about cooperation. What are the factors that enhance cooperation? I think we'd all agree that'd be something, that'd be a good thing to do. One thing is, if individuals had a greater subjective evaluation of the other individuals they're interacting with, the numbers in the game theory cells for the other person would be higher. If you value somebody else's worth higher, their number goes up, and it could actually switch from both defect to both cooperate. So, I mean, it's saying the obvious in game theory terms, if you like. If we value other people more, we would be more generous to them. But coming to more empirical things that aren't so obvious, but I think that come out of the work on this, but I think again they tally with our everyday perceptions. There are studies showing that you get increased offers in these kind of cooperation games in the laboratory if you ask somebody, instead of just looking at their computer saying how much they're going to do, they glance to the left. I glance at Matthew, the next person on his computer around the table. So I just get some contact. It will increase my offers. If I touch him on the shoulder, it will increase the offers. If I converse with him, it will increase how much I give him. So increasing social contact. Increasing reputational consequences. People give more if it's known who they are, who gave the amount they gave, and they're not anonymous. And finally, punishment. Not surprisingly, you can get greater donations through punishment. And people, rather like in the ultimatum game, they will pay, if you like, to spite somebody who doesn't offer very much. You can, in other sorts of games, in public goods games, people will pay some of the money in their pot to punish the free riders. with my public engagement hat on, I did an event with the Ashton group and the Brisbane group when they were here in Ashington, in the Elephant pub here. We played a couple of games. We played the ultimatum game. And I can tell you that in this case, I kept the donors anonymous. But they all gave a half of their, there was £1 in the envelope. And everybody gave a half. All the donations were accepted. And rather nicely, although I said, look, this is a real game, this is a real 10p's up to the pound, take it home. At the end of the evening, all the money was left on the bar table for me to take home. That's rather nice. And we had discussions about these things, and I think it was a useful evening. There were nice discussions around what this could mean for a community. We also played a public goods game, which I haven't been into in detail, but you probably know the public goods game. This is our high-tech spreadsheet, blackboard on easel. But we took a lot of measures. The donations that each side gave, and these were displayed round by round. So there were in this case, we had the Ashton group, and the way I set it up was that usually in the public goods game, you just have to make a decision yourself about basically how much you're going to give to a public good and how much you're going to keep to yourself. And individuals just do it in their heads. But the way I play this in a number of contexts is to get a few people around the table to discuss it. And then you've got the pleasure and the interest of comparing notes about what your thoughts are about public good. And they come to a collective decision for an imagined community. And we had the Ashington group in one group and the Brisbane group in another group. And so they made their decision each round, and it was put, each column here is a round. You don't have to see the numbers here. It's on, by the way, in case I forget, more on the project website, there's a detailed account of all this, with all the numbers if you're interested, and how I ran the game and the other things about the evening. But everybody saw at the end of each round what the donations were, what the cumulative gains were, which is a function of how much you kept for yourself, how much you put into the public good, which is then, interest is added and it's shared out. So there's a little calculation to make about how much you've got all together, from what you kept and what you got back from the public good. What the community has got in total, what the community has got after you had the interest, the share that you've got, and the cumulative value of the community fund. So it's quite rich from a simple game. The results were that in every round, each group gave a lot. They were much more generous than normal in these games. They gave 80 to 100% of their imagined pot. I didn't put all my own money into this one. This was notional money. There was also not the typical decline over rounds that one gets. We could go into that if you want to know why that happens later. But an interesting cultural difference here is that the Brisbane group just took a lot longer to come to a decision. And we've had a few little discussions about this. It seems typical of Australian Aboriginal groups that it takes a long time to decide, because everybody has to have a say in it. Okay, and again, there were useful discussions, I think, after that. Okay, so to summarise that, I haven't gone into detail about the advantages of cooperation. Perhaps I missed it on one of the first slides, but I think we're all aware of we can share our resources, we can share our skills, we can share knowledge, and all these things are of mutual benefit. That's the benefit of cooperation. So it's an enlightened self-interest to share things, because we can all benefit from it. The notions of fairness and reputation are crucial here in the evolution of this in the human species, I think. And Ken Binmore, the game theorist, for example, has even thought that this concern for fairness may be the origin of really what's pretty universal golden rule in different religions, different cultures: do as you would be done by. Right. Adversity and uncertainty. What I'm going to say now is I published with a colleague, Peter Andras, about 10 years ago now. It's in this book chapter. It's basically there if you want to read about it some more. Right. first of all, what do I mean by adversity and then by uncertainty? Very broadly, poor environmental quality. And I'm going to talk about this broadly biologically and then for humans, and then for ourselves. But so broadly, the environmental quality could be resources, predators, parasites, competitors, various abiotic factors like temperature, aridity, humidity, altitude. For humans, here's a distinction I want to make. It can be absolute, in an absolute sense. You can measure it objectively in absolute sense. Poverty, pollution, social exclusion. I picked up a couple of terms from Gibson's talk yesterday. He talks about economic deprivation, reduction in life chances. But secondly, I want to separate that out from relative adversity, the sort of inequality that I know a lot of you are interested in. And the fact that, and this is the Wilkinson and Pickett kind of set of data, that we compare ourselves with others, and that comparison process, whatever the absolute is, that comparison process can lead to psychological stress in an adverse way. What I mean by uncertainty is for any of these qualities that there is uncertainty, a measure by variance. Okay, so we take a quality and it's more or less variable, around an average. Okay. And again, Gibson talked about unpredictability, which I take to be the same sort of thing, of life without work, as an example. So I want now to what I think of as a description of what's going on with the relationship between environmental quality. So here's our independent variable, like environmental quality, any of those ways of measuring it. And so adversity is to the left. Okay, it's low quality. And the effects of that on some benefit to us. And it's either, in biological terms, it could be fitness, or it could, in more human terms, it could be whatever we value. And that may or may not map onto fitness in the modern world. I'm not requiring that it maps onto fitness, but the things that humans value is what I'm going to call a benefit. I'll label benefit. And I'm putting it this way around. I'm going to show you some data afterwards, but I want to build up a kind of description. Okay, to jump ahead, I'm going to show that this, I'm going to argue that this description fits the real world. Okay, but I've chosen to do it this way around. And there are going to be kind of three, if you like, assumptions, if you like, but I think do describe what's going on, and we'll see what we can we infer other things from those descriptions. So the first thing is, I'm going to argue that there's a diminishing returns relationship between quality and benefit. Right. I put here some assumptions which I'll only come back to if people are interested in the more biological things. And I was thinking of just some human things. Perhaps I should. My own notes here. Yeah. It only occurred to me recently that it was partly talking to John last night. That the Wilkinson and Pickett work. I know it from the Spirit Level book. I haven't read the original papers, and I'm sure you know this better than me. So if this is GDP along here, across nations, and this is some, say, health benefit, or there are all kinds of social benefits, aren't there? They are often diminishing returns. Okay. That you reach up here nations that have the highest GDP, and it levels off. Okay. I'll talk. If you want, I can talk about come back to this and talk about more general biological things for some kinds of qualities. So the second assumption or description is that you can do better if you cooperate. Okay, so it goes back to the first half of my talk. There are benefits to cooperation. So if we imagine, in some contexts, individuals, societies, whatever, they're either cooperating or they're not cooperating, the line for cooperation is higher. That's the second. And if you like, if it's not the case, then it's outside the scope of what I'm talking about. You know, if cooperation doesn't work. And so I'm just adding that. But the third thing that's also in the way I've drawn this, and this is really important, is that these asymptotes converge. Because this green line could be parallel to this line. Okay. But I want to argue, and I'd really like some feedback from this, because I've only just recently started thinking about this in the human context and in the economic context. And you know, I'm not explaining this at all. And I would really value, particularly what I write for you, to have some more data and stuff put on this. And again, I could talk about biological things, but in the human case, if one, and I particularly like responses to this, from the inequality work, Wilkerson and Pickett's kind of work, of relative deprivation, basically, and inequality, for the effects where the effects on health and well-being and so on are due to comparisons that people are making, in the more adverse environment down here, well, simply the more people there are above you. So any benefits, so there are going to be more people above you, so there was more benefit to be gained here by cooperating. I'm sorry, I've just realised that's actually an inference I'm going to make, so I think that little bit is circular. But you see, I'd be interested to have your help with the convergence thing here, okay? Because if we accept this assumption, they do converge and they're just not parallel. Well, let me put another, okay, no, there is a more general argument for this, for convergence. If there is some maximum benefit, and at the highest quality, the highest GDP, or whatever the dimension is, and different populations, communities are approaching the maximum possible, if there is one, and it's measurable, then if they're going to, it's likely that they will converge, because there's no higher place to go, if you like. But that's, if you like, a formal mathematical statement I'm making, if you like, but how does it work out empirically? Okay. But if we take those three assumptions, diminishing returns, cooperation is a benefit, and there is a convergence, then it just follows directly that the benefit of cooperation is greater in the more adverse environment. Okay. It just naturally follows from those three things. It's just a part of the same cluster of things, yeah? Because this is the benefit of cooperation, the difference between not cooperating and cooperating. So it's greater in the more adverse environment. Something that comes out so I've just put down there some of the kinds of benefits. I've included very kind of physical things, sharing resources and other things, but also psychological things like social support. But something less obvious comes out about uncertainty. So let's take this case, which I'll call a low variance case. So there's an average of quality here for some particular case along this dimension, and this is the variance. This is the range, actually. It's the range of values around some mean. And suppose in another condition there's a higher variance. Okay. Now you can show mathematically, and Peter Andras, my mathematician friend who I wrote this chapter with, did it, but I can show you informally, from what's in front of you, that with higher variance, or in other words, greater uncertainty, there is a greater average benefit of cooperation, and works as follows. If we look to the left end, left extreme, under the higher variance case, there's a greater benefit there than there, okay, to cooperating. So there's a difference between cooperating and not cooperating again, is what I'm after. Of course, if you go to this end, you get the other way round. As the two converge, the benefit under high variance is lower than under low variance. But, as you can just see, because of the convergence, the difference at the right-hand end, the loss at the right-hand end, if you like, of the high variance, is outweighed by the gain at the left-hand end. So that's just for the two extremes, but you can see incrementally it holds all the way through. And if you do the calculus, you know, it's supported. Is that clear? So that's something that is also just follows directly from the three assumptions, but it's something that you have to do a little bit of work to see. So I think there's something interesting here about uncertainty and benefit. So the benefit of cooperation increases with uncertainty. So let's have some examples. And there are more examples in this book chapter, but it seems to be a very widely applicable set of phenomena, the case. If we look first at adversity, there's this wonderful study of plants in 11 alpine centres around the world, mountain ranges around the world, comparing alpine and subalpine. So alpine is the more arid, lower temperature, windier environment. Plants benefit from neighbouring plants because they're sheltered by them. They compete with neighbouring plants because they compete for nutrients in the soil. And this lovely study shows by taking plants away and looking at the effects, the cooperative effect is more dominant at the higher altitudes. In the more adverse environment, the plants gain more from cooperation than they do at the lower, less adverse environments. For nematodes and also bacteria, if there are toxins in the environment, they gather together, they put out defensive chemicals, and they gain from the scale of these defensive chemicals they're putting out from each other. In all sorts of animal groups, fish schools, mammalian herds and others, and I've got references here, under predation risk, the group size increases. And there are things about vigilance for predators as well. Humans, from the psychological literature, in-group solidarity increases under threat or stress. Various social psychological studies. Uncertainty. Hunter-gatherers forage cooperatively when and chimpanzees and lions, when their prey is unpredictable. Lab study showing that if money is acquired as a windfall, it's managed by the experimenter. You flick the wheel of chance, fortune, oh, I got some money. People are more likely to share it in a kind of ultimatum game kind of way, and others want to ask for more if it's a windfall compared to another conditioned experiment where you have to earn the money. So if it's unpredictable, okay, you get it by chance, you're more likely to share it. Do you know Eleanor Ostrom's work on common pool resources? Wonderful work. Common pool resource groups are more successful under environmental uncertainty. Coastal fisheries, for example. You know, this comes out an enormous amount of work on successful and unsuccessful common pool resource groups. Okay, maybe I've been a bit oversimple here. You may think I've been very oversimple. But what's going on down here? Does it really stop like that at the bottom? You know, just okay. Not necessarily. Supposing it's like that. Supposing that under very adverse circumstances, things are so bad nothing will help. And in that case, the maximum benefit is at an environment of some intermediate quality. I call it Q star. Okay. And you've really got a mirror image either side of that. So what I said about adversity, it's true for the best environments and for the lowest environments. Yeah. And then we'd have a rather, couldn't do much with that because we could say that things would be best at the top end and the bottom end. But from what I've shown you, there's a lot of evidence from the few examples I've shown for the case that that we don't have that. Just looking at the data. So what's going on? So if things are like this, in the most adverse environments, cooperation cannot help. And a possible example here, the case of the Eek in Uganda that Colin Turnbull studied. And in these people, they were, in their past they were hunter-gatherers, but they were also agriculturalists. There was a famine in the middle of the 60s, and society fell apart. It was every person for themselves, and people starved, and family bonds broke down. But that case seems to be rare, and I wonder, because of that, if what's going on, even if this is the case, in fact, perhaps it is the case through history, and in biology more generally, but these populations just die out. I mean, the Eek have not died out, they're still there in Uganda. But in extremis, perhaps we don't see much of this because it's so extreme that the population just doesn't recover. And so we don't see many examples of that. So finally, it's my final slide, on all that. So I think I'll just mention again about uncertainty. I think there was something perhaps a bit new there that comes out of those assumptions that one might apply for uncertainty. More generally for adversity, one can think about this, approach this in different ways. You can be rather despairing of this. You can think, well, see, it seems that things have to get really bad before we do something for ourselves, to be bumped into cooperation. But I think I would take a more positive view, and this is partly an evolutionary approach to things. You could put it this way, well, we get better when things get worse. And cooperation is scaled, if you like, adaptively to need in terms of adversity and uncertainty. And cooperation is, it's responding adaptively to environmental needs.
A fair bit of what you're saying here, trust, for example. I mean, you mentioned it, but you didn't really build a lot onto that. No. But a lot of the research showing that trust is very crucial to build up cooperation, and institutions, trust-building institutions, are very important. And I'm kind of wondering, in your sort of scenario of things getting worse, things getting better, and cooperation adjusting to that, but then institutions are sort of the stable factor in between, so they could mediate, right? So I mean, in a sense, whatever, we build institutions that generate trust. Situations might change, but the institutions are still there, and perhaps we've still learned to trust the rules and so on and so forth, and that can help us over hitches, so to speak, right? Things like that.
Two kinds of cooperation, if you like. I'll think of it in two ways, which brings in your comment. And I guess in my talk I was implicitly thinking of individual to individual. So two individuals can get together in a community and share stuff. But the other thing that can happen is that they form organizations. Most simply in a larger group, you've got more skills, more resources and stuff to share. But as you say, it then builds up a kind of stable grouping and a set of rules and so on that has its own power and stability. And, well, coming to the practicalities, it can then apply for funds to do something for a community as an organisation, which you can't do as an individual. But, yeah, that is another level that I should, I'd like to bring in, yeah. So beyond the individual, there's the organisation, yeah. And it's something, I guess I haven't thought about it too much because thinking broadly biological, I think it only applies to ourselves.
Trying to apply this to a scenario where there might be huge levels of quite sudden cooperation amongst people who've got a lot of agency, say in a village where a gypsy traveller encampment has arrived over the weekend, and there's a great deal of sudden cooperation amongst villagers to stop this encampment.
Yeah.
The cooperation, and it struck me on that third or fourth chart, where there is a lower level or possibility of cooperation in extreme adversity. It's, yeah, because there's something about exclusivity in cooperation. People are cooperating to stop other groups cooperating with them, if you like. So this is our land and we are going to guard it fiercely through our very strong bonding capital as people in the village who are protecting our space. And then when there's an inequality of agency, if you like, and more extreme adversity in the group that should be cooperating to try and stake their claim, if you like, to the land, the gypsies and travellers. I'm just trying to make sense of it, and that helped actually, because if one group is in more extreme adversity, even in the same place in the same time, but their wider context of living means they're in more extreme adversity, you can see why there are different levels of cooperation amongst the different groups. So I'm thinking out loud, but I thought that was fascinating.
Yeah, it's like football teams. Football teams do better at home, and it's, you say the conditions are exactly the same. The field is identical, but they do better at home because they're defending their territory, and psychologically they're defending their territory. And they look at male players, their testosterone goes up in home games.
Right.
It's higher than in away games.
Right.
So there's obviously some thing in human beings that we want to protect, and maybe that's why the villagers cooperate, because it's like an invasion. They see it, we have to
that's
defend.
how they see it.
Yeah, whereas the ones coming in are the away team in a sense.
Yeah.
They don't own the space in the same way, and
But ideally you'd get them cooperating with one another, sharing their shared sense of the land. If I'm thinking of
Your two groups, your travellers and your
the
residents.
travellers and the residents. In an ideal world, there wouldn't be this pitch battle over the land. There would be cooperation between the groups, and that's what I'm struggling with a little bit.
Okay, well, a couple of comments. Of course, cooperation within a group can be used for all sorts of powerful things, and some of it can be against others. Yeah, so it has those advantages for the group as well. And mapping onto that, there are two camps in the understanding of the evolution of cooperation. I haven't talked about that at all, but one says that for the evolution of our cooperative nature, it was necessary that groups were competing with other groups, and there are models of all this stuff, and they think it was necessary, and there was in fact a kind of group selection, which for most biologists is anathema most of the time. But so and there was competition between groups, and beating other groups was necessary for the evolution of cooperation. But another psychological comment about your residents and your travellers, and this is a whole other topic, but I've heard it mentioned once or twice, and it's in-group, out-group discrimination. And I don't know if you know the psychology of this, but I happened to be, when I started out my research career in Bristol, when Henri Tajfel, the French psychologist, was in that department. Do you know him? Okay. He did what's called the minimal group experiment. The in-group, out-group phenomenon and its power is, you should read Tajfel. What he did and I can still see these 12-year-old boys running around as subjects. Basically, he showed you can set up the in-group, out-group distinction in somebody's mind, just like that. He had these about 12-year-old kids in a laboratory. He showed them slides of Paul Klee's work, paintings, and Kandinsky's paintings. You know, these are two abstract painters, very formal squares and things, and very squiggly ones. Which do you prefer? I prefer Paul Klee or Kandinsky. Then he simply got them to reward people themselves or somebody who liked the other sort of painting, or somebody who liked the same painting as them, or the other sort of painting. They had a whole choice of what they should give in pennies to the other side. And they discriminated. They would even give themselves less than they could do if somebody who liked the other sort of painting got even less. And Taschereau was doing this work because his experience as a Jew during the Second World War, you know, how did the Nazis come to do what they did? You know, there were people looking for answers to that. I mean, personally, I think in-group and out-group discrimination is the biggest human problem in the world. And even in an evolutionary sense, it does, because it's so powerful, it does support this notion of, well, we can leave cooperation out of this for now, if you like, but competition between groups being enormously powerful in our evolution.
Like in the public goods game, you said that it typically declines over rounds. Yes. So I just wondered why that was.
Okay. It seems to be. It seems to be because, okay, some people are being generous and some are being mean, and the generous people, they look at the mean people and they say, oh, I'm being taken for a ride here. I don't like that. I'm not going to keep giving all this. And so the influence seems to be in a negative direction. I'm being taken for a ride. I'm going to give less the next round. It could be the other way around. It could be the mean people are thinking, oh, well, they're generous. I should do that. But it's not. That seems to be what's happening. And so you can maintain cooperation and donations by social contact, by reputation. So here's a nice study. So punishment I've already talked about. You can maintain but you can by reputation. This is a nice study by Manfred Belinsky, who, like me, started out as a biologist. This is the typical decline over rounds, donations, over 7 rounds. What's happening here, so these blue are the same public goods game, but look, they're maintained. Because in between, you get to, after each round here, you get to play a dyadic game with somebody, and you get the opportunity to get some advantage out of a dyadic game. So your reputation is more important here, because it has impact on these intervening games, and it maintains the cooperation. So that's will you contribute to the public good? And this is an indirect reciprocity game. Will you give to X? Okay. But it depends on reputational scores.